All right, so let's talk about how to solve a polynomial when it doesn't factor. We're going to use a whole bunch of series of steps which we're going to build over the next couple of days. What we're going to talk about today is a thing called the rational root theorem. The rational root theorem, what this actually does is it gives us a list of potential rational numbers that are roots to a function. So the way we're going to accomplish this is through a basic process where we need to know what the leading coefficient is and the constant, and one of those is going to be called P, the other one is going to be called Q. The biggest mistake I see students do is they want to do it alphabetical. So here I have an equation, f of x equals negative 2x to the fourth plus 13x squared minus 21x squared. I think that one's cubed. What am I doing? Yeah, that's cubed. That should be cubed, or I would have just combined like terms and see if it factored. So minus 21x squared plus 2x plus 8. Well, right off the bat, I always look to see if it factors, but I have an odd number of terms, so I can't factor by grouping, and the AC method ain't going to work on this. So my next option is let's generate a list of possible zeros, and then we're basically going to be just checking them. And we have different ways that we can check them, and we can have different ways that we can narrow this list down. So here's what we're going to do. My leading coefficient here is negative 2. We're going to call this Q, and my constant is 8. We're going to call this P. Now what we're going to do is we're going to do P divided by Q, but what P actually is, we're going to use negative 2 for the Q, but what it actually is all the factors of that number. So what I like to do is this. I like to do P, and I'm going to look at 8, and I'm going to think, what are all the factors of 8? Well, I know plus or minus 1, plus or minus 2, plus or minus 4, and plus or minus 8. Simply because 1 times 8 is 8, negative 1 times negative 8 is 8, positive 2 times positive 4 is 8, and negative 2 times negative 4 is 8. So these are all of my factors of 8. This is really what my P is. I'm going to use my constant to find my P. My Q is the same thing. It's going to be all of the factors of negative 2. And this should be a curly bracket. It's a set. So it's going to be plus or minus 1 plus or minus 2. Because positive 1 times negative 2 is negative 2, and negative 1 times positive 2 is still negative 2. So once I have these factors, I just do P divided by Q. So P divided by Q is going to be, well, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, all over plus or minus 1, plus or minus 2. I like writing like this the first time. I actually write this out like this every time. What this tells me is that everything in the numerator goes with everything in the denominator. So my list of P over Q is 1 divided by 1. Well, that's plus or minus 1. 2 divided by 1. This gives me plus or minus 2. 4 divided by 1. This gives me plus or minus 4. 8 divided by 1. This gives me plus or minus 8. All right, so 1 is done. Put a line through it. Know that you're done with the 1. Now let's move on to the 2. 1 divided by 2 is plus or minus 1/2. 2 divided by 2 is 1. I already have it. I don't need to repeat it. 4 divided by 2 is 2. I already have it. I don't need to repeat it. 8 divided by 2 is 4. I already have it. I don't need to repeat it. And there, ladies and gentlemen, is a list of possible rational roots. Now, while we're doing this, I will promise you there will at least be one of these numbers, a positive 1 or a negative 1, positive 2, negative 2, positive 4, negative 4, positive 8, negative 8, positive 1/2, negative 1/2, that will touch across the x-axis. We won't do any where you won't have any in this list because that's for a different type of class. But for right now, whenever you generate this list, you're guaranteed to have at least one that will cross the x-intercept. And we're going to show other videos on how we can narrow this list down, because as of right now, I got 1, 2, 3, 4, 5. I have 10 different options to check, and I don't want to check all 10 if there's a way I can narrow it down. That's it. That's rational root theorem, being able to generate a list. That's it. Hi, I'm Mr. Buzzard, and these videos are supplemental instruction for my students. If you found the video enjoyable, make sure you click the like button and click subscribe, as well as the bell for notifications to receive future videos on high school mathematics.